Hello and welcome back. In this video I want to talk about VTP or VLAN trunking protocol. We've all probably studied this or dealt with it in some way, shape, form, or fashion through maybe the ENT or the CCNA. But VTP we all thought was lost in the wind, right? We all thought it was gone. We were never going to see it again. And it's reared its ugly head, I guess we could say, back into the data center environment. Originally, within the NXOS switches pre-511, we could only run VTP transparent mode, and the only reason it was there is because it was basically a band-aid between maybe some of our legacy switching infrastructure that was still supporting and still running VTP. So just for instance, we had two switches. Maybe we had a 3750 here. We had a 3560 over here. And we were running VTP on these guys, but we maybe deprecated and replaced a switch with some NXOS device in here. And all of a sudden we didn't have VTP support on that guy. Well, what they did is they released transparent mode on these so that we could at least forward on the VTP advertisements from this guy to this guy. Okay, so we could still technically run VTP in our environment, but the NXOS device was not actively participating in it because it was just transparent. Now, with that said, hopefully you've become accustomed to the different modes that VTP can run in, because post 5.1 is a whole different story, right? Post 5.1.1, we had the ability to support these different VTP modes and implement them within our NXOS infrastructure. Now, those port modes are still the same ones that we've always seen. We still have server, where we can create, modify, and delete VLANs. Okay? We still have client that can just participate and get the VLANs and remove the VLANs that the server tells it to. We still have transparent mode where we will not sync, but we will forward messages. Okay? So we still have the ability with transparent mode to forward on messages that we receive, but we're not going to actively sync ourselves with these other VTP advertisements. What's unique about transparent mode is it gives us the ability to use extended VLANs. So we have extended VLAN support. Now, why is this important? If we're using anything, remember, over 1006 and above, they're considered extended VLANs. So we need transparent mode if we're running extended VLANs. So this is something I'll show you on the CLI that it won't actually update unless we're in transparent mode. Now, VTP mode off, they sort of consider it as a new mode, though I think it's been around for quite some time. But essentially, it has no participation. But they use it because they still want to read via SNMP the VTP MIB file. So they're all still applicable modes, and what I'm going to do is I kind of take you through these modes on the CLI, is also show you just how we configure a basic switch trunk port, how we configure an access port, and how those modes affect VTP, because as we know, VTP can only run on which kind of ports? Trunk ports, right? So I'll say trunks. We got to have trunks to run VTP, otherwise it's not going to work. We will show you that as well. So it's just some things that we need to think about as we move into this CLI presentation about these different modes, how we're going to implement them within our data center, and what each of them do. Now, we also still have the ability to use VTP passwords. Okay? Now, we all know, or we probably have seen, or we will see, that it's easy to show this using one simple command, show VTP password. Not too hard to remember, right? But we do need to know it's there, and that all passwords have to match on all our connected devices. Now, within most infrastructures, say we had another switch down here. What we're going to want to do is set most of our devices to client mode. So maybe this one's a client. This one's going to be a client. And then we're going to pick a server. This server is where we're going to generate our updates, okay? So this server is where we're going to actually go in and we're going to say VLAN 10. And when we create VLAN 10, VLAN 10 is going to propagate up to these guys, right? When we delete VLAN 10, they're going to delete VLAN 10. So our server is where we control what VLANs are active in our environment. Now we also have the ability to prune with VTP, and it is called VTP pruning. Now what VTP pruning does is it will stop the sending of traffic along a specific link or to a specific switch if that switch does not have an active host in that VLAN. So if all this host is doing is has trunks that VLAN is forwarding STP on, so say VLAN 10, and this is the only spot it's forwarding on, that VLAN will be pruned so that broadcast messages, unnecessary broadcast messages in this instance, aren't sent out to that switch, to that 3750 in this case. Now the second that a host is connected in VLAN 10, it will remove the pruning so that broadcast and other traffic can get to that host. So what does this mean? This means that we know now that VTP interacts with spanning tree to figure out, is it actively forwarding, based on a host port or a trunk port, or is it forwarding, is that VLAN even there? Are we sending BPDUs for it? What's connected? So there are some tightly wound details surrounding VTP and spanning tree where it knows this kind of stuff is happening. So again, the second that host is connected, we are now unblocking or unpruning VLAN 10 from those links so that messages can get to that host. So let's go over to the CLI and take a quick look at how we do this. So now we're here. Let's take a look at 5K1. So we'll say show VTP. Show VTP status. Well, what's going on? Well, our caret's showing us what's wrong. Is there any? Nope, no VTP. What does that mean, guys? It means we need to turn on a feature, right? So let's say feature VTP. Go over to this side, to this switch, and we'll say conf t feature VTP. Now when we look, by default, let's just say show int e1/5, and we'll use the switch port command here so that we can view the switch port details for interface Ethernet 1/5. Now when we look at it, the operational mode by default is access. It's going to be the same on both sides, guys. So what I want to show you is that when we configure VTP, if it's an access port, we're not going to get those updates that we think we should get. So on this side, let's say VTP domain, and we'll just set the domain to IP expert. We'll say VTP pass, or actually let's leave out password for now. I'm going to say VTP mode client. Let's go back and I'll show you all the available options. Those 4 options that I showed you. So we'll say client. Then we'll go over to the other side and we'll set it up too. We'll say VTP mode server, which is the default, and we'll say VTP domain IP expert. Now we have an access port. If we say show CDP neighbor, I can see that guy out interface Ethernet 1/5. So let's go ahead and go back over here. He's in client mode. Let's say VLAN 10. Oh, as we figured, we cannot create a VLAN or modify it when we are in client mode. So we need to come over to this side and say VLAN 10. We'll exit out so that it's actually applied, and we'll say show VLAN summary. Show VLAN brief. We see VLAN 10 in our database. So if all's well, we should see it over here too. And it's not. Now why is that, guys? Why do we not see it there? Well, if we think about it, as we mentioned in the previous when we were looking at the slide, we have to have a trunk port up for this to work. So what we need to do is configure this as a trunk port so that VTP can actually work. So let's go in here and let's configure our first trunk port. So we'll say int e1/5. Now to configure trunk, it's the same as our traditional iOS. We're going to say switch mode trunk. Now if we go into verify and we say show int e1/5 switch port, we can see now that our operational mode has changed to trunking. We are using a native VLAN by default of 1. So let's go in and do our other side. 1/5, we'll say switch mode trunk. Show int e1/5 switch port. We always like to verify, right? So we are trunking. We can see operational mode is trunk. Now, coming from the iOS world, we're also used to seeing that ISL option sometimes. Within NXOS, we only support .1Q trunking. Okay, so we don't have to say switch trunk encapsulation .1Q or ISL. It's by default, and it only can be 802.1Q. So let's go in and we'll say show run int e1/5. We can see our switch mode trunk. Now we come back to this side now that we've created a trunk and see if our VTP is working. And sure enough, guys, we even have VLAN 10 over here now. What happens if we go back to this side? Let's say VLAN 10 name VTP test. Exit out. Let's see if it updates the name for us as well on the other side. Check that out. Updated our name for us. Awesome. So now we've verified at the most basic level that VTP is working across our trunk, right? So let's set a password now. Now that we've verified that it's working, let's set a password and then we'll do another test. So we'll say VTP password Cisco. We'll say show VTP password. We can see that it's Cisco. So let's go over to the other side now. Let's create VLAN 20. We'll name VTP test 2. Exit out. Let's go over here and just see if it worked. We don't see anything. Why? Because we have that password mismatch, right? So let's go back over to our other side and we'll say VTP password Cisco. Now let's see if it updated. Not yet. So what's going on here? Maybe we'll just wait just a little bit and we'll see if it actually updates this. It might or it might not. So let's go back over to the other side. We'll make sure that's in our database. Okay, we do have VLAN test 2, but what's happened here is our VTP has gotten out of sync. So let's make sure. We'll say show VLAN ID 20, not found in our current database. So if we say show VTP status, which is our ultimate kind of verification command for VTP, we could see the configuration revision on this guy is 2. The configuration revision on this guy is 3. So in this instance, we have a couple of options that we can take. One of those being that we can go in, we can change this guy to server. We can say VLAN 20, exit, show VTP status. We can see now we have a configuration revision of 3. We can say VTP mode client, show VTP status, show VLAN brief. Now we have VTP test 2 actually. You see how it sucked the name back in from the other side? So now we've kind of got our database back in sync at this point. So now we actually have a working password, a working VTP domain. So what else I mentioned was that if we're running outside of transparent mode, we can't actually pass VLANs over that are in the extended VLAN range. So just to prove that, let's go over to this server. We'll say conft VLAN 1010 name extended. So these VLANs, though I can create them, are not going to propagate to their peers. So if we look over here and we say show VLAN brief, we're never, ever, we could wait forever, we're not going to see VLAN 10 actually propagate over to this side, or VLAN 1010, excuse me. We have to sit here and either create it ourselves, or we have to switch everything to transparent mode and just manually create everything on both sides. So, or just not run VTP at all, right? So we have a couple options there, but I just wanted to show you that anything over that VLAN, that into that extended VLAN range, is actually, it's not going to be propagated with VTP. We just can't do it. So just to prove it, we'll show one more time. It's not going to show up here, guys. So that is VTP in a nutshell on the NXOS devices. So we do have the opportunity available to use VTP if we want. Do I recommend it in any modern data center? No, not really. I'm one of those let's create VLANs manually on each device kind of guy. So I like to go and actually control manually. And if I'm going to do something like pruning, I use switch trunk allowed list, which I'm about to show you. So let's just turn off that feature. Let's blast all that VTP config out of there. Say no feature VTP. Go over to this side. We'll say conft no feature VTP. We'll say show VLAN brief. Okay, we still have our VLANs. Still have our VLANs. So now we have these VLANs out here, and let's create VLAN 1010 over here. Now they match on both sides. So what I want to show you guys is when we create trunks or access ports, just the basics, the gists of how we create those. So let's go in and let's create our first access port as an NXOS admin. Now an access port is what? It's usually connected to an end host or a router. So we're going to place that port directly in the VLAN. We're not going to do any tagging over that interface. So at the most basic level, we'll just say int E120 here. It's already in access mode, but what we can do is just to make sure, right? We like to be sure as administrators. We'll say switch mode access. We'll say switch access VLAN 20. Now what else would we want to do for an access port? We want to go ahead and make that a port type edge. So we'll say spanning tree port type edge. Then maybe we'll give it a description. Access VLAN 20. So now if we take a look at show run int E1/20, we can see that it's a basic access port that we need to no shut. Now notice what doesn't show up here is the switch mode access. If we wanted to see that, we could say show run all section 120. We could see all the defaults for that switch port, which as you can see, there's a lot of default commands, and that's why they don't include them in the actual running config. So when we look at just the base config that we did, we did a switch mode access and a switch access in VLAN 20, and we enabled port fast, but with the NXOS syntax. So now if we do our ultimate verification step and say show int E120 switch port, we can see that we are in Ethernet 120, that we are access mode VLAN 20, and that's the VLAN name. So this is awesome. We've created our first access port as NXOS admins. Now we want to create or actually modify that trunk that we did before by using the VLAN allowed list. So if we look at 1.5, which is connected to our other switch, we'll say show run int E1/5. We can see that we're just doing a basic 802.1q trunk. Now how do we say only pass these VLANs over that trunk and no others? Let's look at our VLANs again. We have VLANs 10, 20, and 1010. What if we just want to pass 10 and 20 over that trunk? We can use something called the VLAN allowed list for the controlling what VLANs can be propagated over that trunk. So if we go into there, we'll say int E15 switch trunk allowed VLAN, and then we just do our list, guys. We say 1 or 10, 20. If we already had an allowed list, we'd have to come in here and say allowed VLAN add 10 and 20. But since this is our first and initial list, we're just going to say 10 and 20. So now if we go back up and we look at that interface, we can see our switch trunk allowed list. So if we ever have a problem where a VLAN is not actually writing a trunk that we need it to, maybe checking this VLAN allowed list on the trunk is going to be one of the first steps we need to go and do. So for verification on which VLANs are going over these trunks, we can use a pretty simple command, show interface trunk. And let's narrow that down. Let's do show interface Ethernet 1/5 trunk. This command lets us go in and see which VLANs are allowed on the trunk and which ones are forwarding, STP forwarding on that trunk. Now notice that I took 1010 out of there, and that's why it's not showing up in this list. If we go to the other side and we said the same thing, because we haven't done any allowed list on this side, and we said show int E 1/5 trunk, we're going to see all VLANs on here, and every VLAN is actually forwarding over that trunk right now because we have not done the allowed list. I hope you guys have learned something here and that VTP is actually supported on these NXOS data center switches, and that we also have the ability to modify trunk allowed lists so that only certain VLANs can be propagated over that trunk. I look forward to next time when we talk about port channeling on NXOS devices.